Okay, hello. I like to talk a bit about Young's experiment. Just I quickly go through the concept and then we answer some questions together. So firstly, when I'm talking about Young's experiment, it means it's double slit. So there are two slits that we have here, S1 and S2. The distance between two slits is showed with D. The distance from slits and screen we showed with L. And then y is the distance between from central bright point and different bright points on the screen. And then this sigma actually is the difference between distance traveled by light from S2 and S1. So if we show the distance traveled by light from S1 R1 and light from S2 with R2, if R2 minus R1 is m lambda, then here at point P we have constructive interference and we have bright band. If R2 minus R1 actually is m plus half lambda, then we have destructive interference and we have a dark band. Right now I want to go through some questions, but beforehand just one more thing. Remember that here the theta is really small and also this part is equal theta. So for this triangle I can write one equation for sine theta. So I can say sine theta actually is sigma divided by D, that for bright band, this sigma, that is this difference between distance traveled from point S2 and S1 should be equal m lambda, and D is the distance between two slits. And if I can say this triangle, then with the angle theta here, so I can talk about tan theta because here I have the y, I have the l, so I can say tan theta equal y divided by l. And because theta is really small, we can say sine theta equal tan theta equal theta. So if sine theta equal tan theta, actually we can say so m lambda divided by t equal y divided by l. And by doing that, if we have lambda, if we know m, d, and l, we can find y, that is distance from this bright band and central band. Right now, let's do one question. Young's experiment is performed with a light of wavelength 700 nanometer. Okay, so this is important information, 700 nanometer. This is our lambda. The slits are 1.10 millimeter apart. So this is our D. But remember, everything should be in meter. So D is 1.10 millimeter and wavelength is 700 nanometer. That later on we need to convert both of them to meter. And the screen is 5.40 meter. So this one is our L, 5.40 meter. How far apart is the first bright fringe? So when I say first bright fringe, it means we are talking about m equal 1 from the center line on the screen. Okay, from central line on the screen. Okay, let's see. So if I say this is my slit, so this is my screen. Okay, so my central point, and I want to find this one, this distance, that is y. Okay, And then I know from this point, as you remember this image here, so we can use this formula. Sine theta is sigma divided by d, that is m lambda divided by d. That in this case of our question, m equal 1. And then on the other hand, we know tan theta equal y divided by l. So if I use these two formula in here, I can say sine theta equal m lambda divided by d, and tan theta equal y divided by l. And because theta is really small, we can put them equal. So m lambda equal m lambda divided by d is equal y divided by l. And right now we just look at our data here, m equal 1, just I put m1, okay. Lambda here is nanometer, so I need to convert it to meter. You know, we need nanometer to meter, just we need to times it by 10 to the power of minus 9. So we put 700 times 10 to the power of minus 9. And here, D is 1.10 millimeter, just I converted to meter. So we become 1.10 times 10 to the power of minus 3 meter. This one also meter. So I put it here, 1.10 times 10 to the power of minus 3 meter. Then lambda is something that we want to find, and L is equal 5.40. Okay, as a result, if I calculate here, then y equal 5.40 times 1 times 700 times 10 to the power of minus 9 divided by 1.10 times 10 to the power of minus 3. That if we do calculation is equal to, just a small calculation. So we can see it equals 3.4 times 10 to the power minus 3 meters. So this y is the distance between central bright line and the first bright line. Okay, thank you for watching.